In 1985, the VH-60 Executive Transport Helicopter program was begun. Its mission is to conduct immediate air transportation or evacuation, especially in emergency situations, for the Executive Office. The VH-60 is operated by Marine Helicopter Squadron 1, which also operates the familiar VH-3D presidential helicopter. Based on its successful avionics upgrade program of the existing VH-3D Executive Transport Helicopter, the Naval Air Development Center, NADC, was tasked to design, develop, and integrate the VH-60's avionics system. An avionics laboratory was established to provide design engineers and coders a facility to develop and test the software. Pre-flight software testing was accomplished by the use of equipment which simulated both the helicopter and the avionics. The laboratory also supported integration efforts by providing a station configured with the same avionics as was installed on the actual helicopter. Interface testing, software checkout prior to installation, aircraft integration, and flight crew training were all accomplished with the aid of this station. With the completion of the avionic design phase, detailed block diagrams, wiring lists, and installation instructions were sent to the manufacturer, Sikorsky Aircraft, for incorporation into the aircraft system. At Sikorsky, NADC engineers checked out ferry packages of avionics for each helicopter. Then the aircraft were sent to NADC for the next phase, system integration. All avionic wiring was checked for proper installation. Because of the vast amount of avionics aboard the VH-60, the wiring is both extensive and difficult to access. To speed up the wire checkout process and ensure its accuracy, an automatic wire harness tester was developed by NADC. This tester incorporated a computerized wire list of the whole avionics system. By using the tester and breakout boxes, NADC engineers could check for all possible combinations of miswiring in a quick and efficient manner. As wiring problems were identified, a Sikorsky on-site support team made the appropriate fixes. When all wiring checked out, the avionics were reinstalled and a series of unit tests were initiated for each piece of equipment. For example, TACAN, VOR, ADF checkout with a standard test sets, radio power output measurements. These unit tests confirmed proper functioning of the avionics and provided calibration of the equipment when needed. Once all avionic components were checked and a data collection system installed, the VH-60 was closed up and made ready for engineering flight testing. However, prior to flight testing, the entire avionics system was tested on the ground. The attitude reference and heading systems were calibrated to the flux valves, and the communication systems were checked between the aircraft and the avionics laboratory. Flight testing typically involved 10 flights per aircraft in order to confirm navigational and directional finding radio accuracy and the radio ranges of all RF systems. Communications system checkout flights with the White House communications nets were also conducted. The data were then reduced and analyzed between each flight. After flight testing, each aircraft was returned to Sikorsky to be painted and made ready for final delivery. Successful flight testing at NADC ensured that each VH-60's avionics system was ready for the critical missions it was designed to perform. At the first delivery ceremony, then acting Deputy Assistant to the President and Director of White House Military Office, the Honorable James C. McKinney stated,
"Outside of the circumstances of war, no aviation project has moved from concept to reality in such a short period of time."
A major portion of the program's success can be directly attributed to the Naval Air Development Center. Not one major program milestone was missed during the development, and all aircraft were successfully integrated on or ahead of schedule and within budget. NADC continues to support both the VH-60 and VH-3D helicopters as the life cycle support activity for the mission software and as engineering consultants for avionic development. The Center is currently working on global positioning system upgrades for both helicopters and continues to provide technical support to the Naval Air Systems Command and Marine Helicopter Squadron 1 on future avionic upgrades. The benefits derived by the Center from this program have been both numerous and rewarding in terms of the technical quality of the work and the hands-on learning experience it has provided.